let me show you something that I think you didn't notice. I want you to pay attention to this. All that you are watching here, it's the sun, no? The occultation circle, so we can have these views of one camera and the blue one another camera, so we can see the plasma, okay? Now, what you see here, spread here in this blue area, are stars. These are stars. That's why when you move this, when you play, they all move in the same rate, because in fact they are not, well, they are moving, but this movement, this direction you see because of the Earth's rotation. As we rotate to one side, the stars rotate to the other side. That's our view, right? Very easy to understand this. So, if you see something, all of them are at the same rate to our eyes. If you see something at a different speed, that means it's not a star, right? Now look at this. These are stars. This dot here. Pay attention to it. I will click play and you will see the stars at the same rate of movement, at the same speed, but look at the difference of this. Did you see it? Watch again, here. Again. You see? It's a different speed, look. Much fast. Look that, what I told you. Now, there's two things. There's the noise as well. These small traces that you see flashing all over. It's those are debris from the plasma, and the camera capture those debris as well. But this is not a debris. This is something that it's at high speed here. Bam! Better saying. This is not a debris. And look, skeptical people can say, well, Tiago, that should be Mercury or something. No, because not Ceres and not Mercury. Because I was watching here. So we are here. Now look, Mercury, it's here. This is Mercury, you see? At the same rate, look. It's not, in fact, it's not the same rate, but to our eyes, it's at the same rate, you see? Because a planet, a star, it's different. But they move at the same rate to the camera, you see? If we put Mercury a bit to the right, that means that the camera is a bit to the left to the Earth, of the Earth. That's why it's capturing like this movement. Mercury, it's here, the sun. You see? So the camera, it's more or less here. It's on the Lagrange point. And Ceres, if the camera is here, the object is passing here. Here. From the right side to the right. Ceres, it's here. Venus, it's here. Well, Venus will be very visible. It's not Mercury. If you notice, this is 48 hours ago, and the object goes here, and it's very fast. If it was Mercury, it will not go so fast. To be here, Mercury, you would have to have something like this. Like this. The view, which we don't have. From here, not from Earth. From here. From this position, so Mercury could be at the right, and it will have to Mercury go at a speed to the right, not in its path. Look at the path of Mercury. Look at the path of Mercury. I will play. Move faster. Faster, 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 faster. You see? It's going behind the sun. This is not Mercury. Look, here. running away from the explosion. Look, I will zoom it so you can see the difference in speed. All the different objects, forget the noise. There are three different things apart from this. It's the coronal mass ejection, so the plasma here, bam. It's the stars and the noise of plasma. Particles. There are particles, you know? But this is not a particle. This is very consistent and it's a high speed here. Bam! And slow down here a bit and then bam again. Look, look, look. But that can be the frames of the camera. You see? The stars all at the same speed. And this, very consistent. Bam! And here, if you notice at the end, looks like it has a tail. Look. I will move slowly here. And it's too big to be a orb. Look. You see? Looks like it has some kind of... Now, the question, the answer to a question. I don't know what it is. I have no idea, okay? I have no idea what it is. Because sometimes we see comets, and here I show you comets being swallowed by the sun. Actually, we can't see them touching the sun because they disintegrate before touching the surface of the sun. The sun is too powerful for that. I don't know. As I don't know, it's all up to our imagination. I say some proposals in the chat. It's cool in it. Now I want to show you something else. Now this we know. Now be careful. I joke with this, but this we know. That is the shadow of Ganymede. It's a moon of Jupiter. This we really know 100% it's Ganymede. It can't be a planet. A rock planet. It can't be even... Because just the speed of it can't be a planet. Planets have, even rock planets, I think they are slower because we captured with recently with James Webb pairs of rock planets on the Orion Nebula, which is amazing. You see, it came from here. There we go. And all the objects, if you notice, all the objects are stars and they move slowly. It does have a tail. Can you zoom it more, please? Man, I can zoom, but I think the tail... Look, I will zoom the best I can. And I will do it slowly, hold on. We'll do like this. From here, the beginning, because it comes from nothing. Here, it's very faint. Hold on. See, it's so faint that it pixelizes. It's far away. Here is a star, and then it passes over the star, and then look. I'll zoom the best I can here. Look. Hold on. You see, here we can't see no tail. But it's all very bright in this region. Remember, this is a camera. Look how he passes at a speed. You see, no tail here. But I think that's because of the camera. Look. Here is when we start seeing something. of a possible tail. At the end, you see? You see? That's where I saw something here. You see? It's not a perfect circle anymore. And we can invert the color. And we see better, you see? That's why I invert sometimes. We can see better the shapes. It makes better contrast. And here you can clearly see something here. They were fueling. They saw the explosion. Let's get out of here! And BAM!
Altitude, velocity, light.